All right, today we are going to be going over 9.1. We have already done sections 2 and 3 for this unit, but to move on to sections 4 and 5, we do have to go back and cover what we skipped in section 1 because we'll need it. Section 1 is going back to radicals, which we talked about in unit 7 a little bit. So we are talking about radical expressions, which are things like the square root of 24, the square root of 3x squared, or maybe the square root of 9xy to the third. And I mean, it could even get crazy, like the square root of 2x cubed over 5y to the fourth. Today, what we're going to really focus on is how to write them in their simplest form. So just like math before Mrs. Homer's class, you learned how to reduce fractions, get them in their simplest form. So 5 over 10, we could reduce. Both of those are divisible by 5. 5 goes into 5 once, 5 goes into 10 twice. So 5 over 10 is the same thing as 1 over 2. So we can do that with things like the square root of 24. We can simplify that. So simplifying our simplest form means that we are going to reduce to the smallest radical. And what this means is the smallest radical means no decimals. Okay, no decimals. So just an example of a few things. If we're talking about taking the square root of 9 and we want to reduce that, obviously we should know the square root of 9 would be 3. Square root means what times itself gives you that number. So 3 times 3 gives me 9. If I'm talking about the square root of 0, again, what times itself gives me a 0? Well, that's a 0. Those are pretty easy, but in this lesson, we're going to talk about things like the square root of 8. Okay, what is that equal to? Okay, because 2 times 2 is 4, so it's not 2. 3 times 3 is 9. Well, that's larger than 8, so it's something between 2 and 3. So we need to figure out what that is. Yes, you can type the square root of 8 into your calculator. It's going to give you this decimal. There's no rounding, there's no decimals, right? We wrote no decimals. So to simplify this, what we're going to do is we're going to break this down into what we call its prime factorization. So starting with this 8, what times what would give me an 8? Good, a 2 times a 4. Can anything multiply to give me a 2 other than 1 times 2? No, that's what prime is. You can't break this down any further without using a 1. Okay, but 4 is not prime. What multiplies to give me 4? Perfect, 2 times 2. So once you're down to all of these 2's, because we can't go any further, we call these our prime numbers. And that's what we're going to use to simplify this radical. So I'm going to rewrite the square root of 8 as a square root of the multiplication of its prime numbers. So that means 2 times 2 times 2, right? I had 3 of them. 1, 2, 3. Now when we're talking about square root here, the magic number underneath this radical sign is a 2 because we're talking about the square root. So I want to pair like numbers. Pair means 2 of them. So I have these two 2's, they become a pair. The first 2 in that pair will come outside my radical sign, then the other 2 will disappear. So now I have a 2 on the outside of my radical sign. This 2 disappeared, but I still have a 2 inside my radical sign. And since this 2 is prime, this won't simplify any further. This would be my prime factorization. So 2 square root of 2. If I go back to my calculator and put in 2 square root of 2, I'm going to get that same decimal. Okay, so I know I reduced it. You just need to make sure you've reduced it completely. 2 is prime, so I know I can't reduce it any further. That's what we're going to be working on today. So we're going to do just these 8 problems, and we're going to work on reducing. So this first one, the square root of 24. Remember, we're simplifying, so no decimals. So the square root of 24, I'm going to type that in my calculator. Square root of 24. Definitely not a whole number, so I can't just solve it like I could with a 9 or a 4. So I'm going to ask, what times itself will give me 24? All right, some of you were thinking 2 and 12. You're right. Some of you were thinking 3 and 8. You're correct. And some of you were thinking 4 and 6, and you're right. It doesn't matter which set of those numbers you use. It will all reduce down to the same prime numbers. I'm just going to use the 8 and the 3. 8 I can factor out further. 8 would be 2 times 4. Can't do the 2, but I can do the 4 one more time. The 4 would be 2 times 2. So I know that I have this prime of a 3, this prime of a 2, this prime of a 2, and this prime of a 2. So this is going to be the square root of 2 times 2 times 2 times 3. So I'm going to pair up like numbers. So my first pair, I have a pair of 2's. So the first 2 I bring outside the radical. The second 2 I just get rid of. I have another pair of numbers, but one's a 2 and one's a 3. So since they're not the same, I can't do anything with those. So I just brought out my 2. And then on the inside, I have my 2 times my 3. Since I can't do anything else with that 2 and that 3, since I don't have another set of those numbers, I'm just going to simply multiply those back together. So I'm going to have a 2 times the square root of 6. And that would be in simplest form. And if you want, you can go back and check. 2 times the square root of 6, is it the same thing as the square root of 24? Yes, I got the same decimal, so I know I didn't make any mistakes when I simplified. The only error that might occur is you didn't simplify all the way. But we know we did because we were just left with a 2 times a 3. Okay, the next one. Negative square root of 48. So I'm not going to worry about that negative sign right now because it's on the outside. So first I'm going to see, is the square root of 48 a whole number? Nope, sure isn't. So then I'm going to break this down. So 48, lots of options here again. I'm going to do 2 and 24. I know 2 is prime. 24 would be 6 and 4. 6 would be 2 and 3, and 4 would be 2 and 2. Okay, so I got all of these prime numbers. So the 2 here, 2 here, 3 here, 2 here, and 2 here. So I can rewrite this as the square root of 2 times 2 times 3 times 2 times 2. Now we're going to look at our pairs. So I have a pair of 2's right here. So I can bring one of those 2's out and get rid of the other one. Then I have another pair of 2's right here. So I can bring one of those 2's out and get rid of the other one. And the only thing I have left in there is that 3. I don't have another 3 to pair that with. So what happened was I brought, let me use these colors. I brought that green 2 out, and then I brought that yellow 2 out, right? And then inside, I still have the square root of 3. Now, all of these numbers that you end up bringing outside the radical here, what's going to happen is you're going to multiply them back together. Just like inside the radical you're multiplying, outside the radical you are as well. So 2 times 2 would give me 4. and then I have the square root of 3. Oops, I almost messed up. Then I need to remember this was negative, so I just bring my negative sign down at the end. So negative 4 square root of 3. So then I can check to see if the 4 times the square root of 3 is the same thing as the square root of 48, which you can see those decimals are the same. Okay, let's do another one together. 162, square root of 162. So first, again, there are many options on splitting this up. I'm going to go with 54 and 3. 54 would be 6 and 9. 6 would be what? Good. 2 and 3. And 9 would be good. 3 and 3. So we got them all down to 2s and 3s. So I know those are my primes. And I like to circle them just so when I go to rewrite them in this radical, I can see them clearly. If they're not circled, sometimes it gets a little jumbled. So we have a 3 times a 2 times a 3 times a 3 times a 3. So I have a pair of 3s. Bring one out, get rid of one. I have another pair of 3s. Bring one out, get rid of one. So I brought a 3 and a 3 on the outside. So that means I'm going to multiply those two together. So 3 times 3 gives me 9. Then inside my radical, I have a 2 still left. So 9 square roots of 2 would be my answer. So go ahead and pause the video and try number 4 on your own. All right, so let's see how you did. I ended up getting negative 16 times the square root of 2. How'd you guys do? All right, let's look at the next ones. The next ones look more complicated, but they're actually not. So number 5, we have the square root of 25 over 64. What's nice about these problems is when they're as a fraction, you can actually separate them. So I can change this to the square root of 25 over the square root of 64. And we should know the square root of 25 is what? 5, right? And the square root of 64? 8. And then does 5 over 8 reduce at all? Sure doesn't. That's our answer. Okay, so same thing on the next one. I have the square root of 6 over the square root of 49. And whatever we get, that's going to be negative. So square root of 6, is that a whole number? No, it's not. All right, so we have to factor this out. So 6 would be 2 times 3. So this would be the same thing as the square root of 2 times 3. Do we have a pair of like numbers? No, we have a 2 and we have a 3. So can we simplify 6, square root of 6? No, we sure can't. So the top, the numerator, is going to stay the square root of 6. And then the denominator, square root of 49. What times itself is 49? 7. So we're going to get negative square root of 6 over 7. Okay, number 7, the square root of 196 over 4. So again, I can separate these. So negative square root of 196 over square root of 4. Square root of 196. I don't know if that's a whole number, so I'm going to try it out. Square root of 196. Just so happens it is. It's a 14. So I know my numerator is going to be a 14. So negative 14 over, what's the square root of 4? Good, it's a 2. So negative, almost stopped. Negative 14 over 2. Can I reduce the negative 14 over 2? I sure can. That becomes negative 7. Okay, number 8, I want you to pause the video and try on your own. Okay, so you should have split them up, square root of 49 over square root of 64. We know the square root of 49 is a 7. The square root of 64 is an 8. 7 over 8 does not reduce, so 7/8 should be our answer. Okay, if y'all have any questions, remember you can email me, you can call me, you can text me, you can also message me in Google Classroom. Okay, so take advantage of all of these things that you can do to get some help from me. And I hope you guys are having a great day.